Hello and welcome to the second in a series of 6 films about the standard level kinetics topic. This one again deals with rates of reaction because that's what kinetics is all about. But whereas in the first film we were looking at what units we might use to measure a rate and how we might obtain rates from graphs, I suppose. Here we're going to be looking at what features of a reaction we might look for to decide how we're actually going to go about measuring a rate. Okay, so we're going to look at the reactants and products and see if there's anything that makes us think, right, okay, this would be an experiment that would allow us to measure the rate of this reaction. Now, why would we want to do that? Well, either because we actually have to design an experiment of our own, or because we're being asked a question about this in an exam. A question like, how would you go about measuring this rate of reaction? Okay, so first of all, just a very quick reminder of what kinetics is all about. As we've said, this is all about how fast reactions happen, and if you're going to measure how fast something is happening, you're going to measure a change in something and then divide that by the amount of time taken for that change to occur. So really what we're going to be looking at here is what sort of changes will allow us to measure a rate. Now, I suppose the simplest kind of change is when a reaction produces something that can escape. Okay, because if it escapes, we can either allow it to escape and measure how the mass of a system changes, or we can collect that thing and then measure how quickly it's collecting. Now, what sort of things are going to escape most likely from chemical reactions? Well, gases. And here we can see a reaction that is producing carbon dioxide. So we could either collect this carbon dioxide perhaps in a gas syringe, or we could collect it by bubbling it through water into a measuring cylinder, and we could measure the volume of gas produced and record the time that it takes. And if we did that, then we could draw a tangent to our curve wherever we wanted to measure the rate, and then by finding the gradient of this tangent, we'd be dividing centimeters cubed by minutes, so we'd be finding a rate in centimeters cubed per minute. Okay, or alternatively, we could just, instead of collecting this gas, we could just allow it to escape, and then the mass of the system would fall because one of our products is escaping. Obviously, the mass of the system in total would never change because matter can't be created or destroyed. Okay, but if we allow this carbon dioxide to escape, then we will lose its mass from the system effectively, and the mass of the system will fall, and we can measure how quickly this mass is falling by again drawing a tangent to the curve and finding the gradient of the tangent. And now we'll be dividing grams by minutes, so it would give us a rate in grams per minute. But really, this film is not about focusing on the units of rate, more about what it is about this reaction that makes us think how we could actually measure the rate. And here, because we're producing a gas, we can use one of these two methods here. So again, we could collect the gas in a gas syringe, or we could maybe do this reaction on a balance so that we can record the mass of the system as time goes by. Okay, now this next method is something that if you haven't studied acids and bases will seem perhaps a little bit mysterious, but titrometric analysis involves doing a titration. And this is useful when the system is not producing anything that is going to escape, but it has got something in it, and in this case we're looking at this acid here. It's got something in it which you could easily react with something else and measure how much of that something else you have to add to react with this thing. So if I had this reaction going on in this flask, say, then I'd have some amount of acid in here depending on how far the reaction had proceeded. And if I added a base of known concentration, and this, as I say, this is something you'll know more about once you've done the acids and bases topic, but an acid will react with a base in, surprise, surprise, an acid-base reaction. And if you know how much of that base you added and what its concentration was, then you can figure out the concentration of the acid in here. And by doing that, you'll know how far this reaction has gone if you know what the initial concentration of your acid was. Now, I suppose using this kind of a method does rely on the fact that this reaction is quite slow, because in the time that it takes you to conduct this titration, you need to be fairly confident that this reaction won't have changed very much, so that the concentration of the acid when you started doing this will be about the same as when you finished. Okay, so that's an analysis of the reaction using something called a titration, and hence it's called a titrometric analysis. Here's another reaction which doesn't produce anything that escapes, but does produce something that is quite different from the other things. Now, in this reaction, we've got colorless substances in our reactants, but we've got a colored substance in our products. Okay, and if we measure basically the color of the solution, or how well it absorbs certain frequencies of light, then we can measure how quickly the iodine is forming. So that's something called colorimetric analysis, where you're measuring how much of this colored substance has formed. And the last one we're going to look at in this film is something to do with conductivity and pH. Again, pH might be something you're not very familiar with if you haven't done the acids and bases topic, but you should know, if you've done the bonding topic particularly, that a solution that's got ions in it will conduct electricity. Okay, so if a reaction is using up ions to produce covalent molecules, for example, then the conductivity of the solution will fall as time goes by. So if you measure how well this reaction system conducts electricity, you can measure the rate of the reaction, because you know that the conductivity will fall as these two ions get used up. Similarly, if you use a pH probe, for example, to measure the concentration of H+ ions in the solution, and again, if you haven't done the acids and bases topic, then you won't really know how pH relates to the concentration of H+, but there is a relationship. Okay, then by measuring the pH, you can find out how many H+ ions there are in the solution and get an idea of what the rate is, or how quickly these are being used up. Okay, so what we were hoping to achieve in this film was really just to have a look at a few different kinds of reaction and look at the reactants and products in those reactions to see how we might go about measuring a rate. In other words, how we might design experiments based on these reaction equations. Okay, as usual, if there's any questions or comments that you've got, please feel free to come and see me or to post a comment on YouTube.